All right, this section we're going to talk about contingency tables, sometimes known as two-way frequency tables. As you notice here, we basically have a frequency table, but now we have two different categories. So one is about their gender, and then the other one is where they live, I'm assuming. So it's a frequency table, but instead of having only one category, here we have two categories. That's why it's called two-way frequency table or contingency table. So here we can investigate the relationship between this category and this category. And let's look at some of the examples here. First thing I notice is that I have a bunch of missing spots. So I'm gonna try to figure out like how to fill that numbers in. So let's look at the female section, the row. I notice the total is 45. And then the first two spaces I have 18 and 16. And I know that they have to add up to 45. So basically what I have to do is, okay, I'm going to take 45. So in order to calculate this part, I'll do 45 and then I'm going to minus 18 plus 16. So it'll be 45 minus 34. That means there must be 11 people there. So I'm going to get 11, make sure that I added it correctly. Okay. And I kind of use the same concept here. On the mountain peaks, there's 11 female, 14 males. That means it should be total of 25 people right there. Okay. Same here for the lake and stream male. We have 16 females, and I don't know how many males, but they have to add up to 41. So I can do 41 minus 16. So they give you 25. So it must have been 25 people here, right? I kind of argue the same way for male row. I know there are a total of 55 males, and we have 25 and 14 filled in already, so I can go 55 minus 25 plus 14, which is 55 minus 39, so that must be 16 here. And then for the coastline, I have 18 females, 16 males, so it'll be 34 total. And one last space, grand total will be just 100. So grand total, I can add up all the numbers on the row or add all the numbers in the columns. So there we surveyed 100 people. Here, I'm just gonna highlight the part that is actually the data part. Like these spaces are actual data, and the rest of it is just total, subtotal, and total. So just gonna keep that in mind. And also for the total part, it's not 200, because if you look at the row total, that's 200, column total is 100. That doesn't mean there are 200 students, 200 people we surveyed. So just want to keep that in mind. So the first question, being female and the coastline, are they independent events? Again, here I'm looking to see if two events are independent. We have to see probability of A. Is this equal to probability of A given B? I want to see if these two things are equal to each other. Again, as I said before, sometimes these numbers will be equal, sometimes these numbers will be different. We'll say these numbers, they are independent if these two numbers are equal to each other. So in this case, we have a female, so I want to maybe rewrite it female as F, and then the coastline, so probability of F given C for coastline. So let's see if I can calculate these two probability and see if they're equal or not equal. So first, probability of female is the first row. There are a total of 45 female students or females here. So 45 over 100. All right, let's look at the second one is F female given the coastline. So again, the bar is given, which is a conditional probability. In this case, I can interpret this as out of. So here I'm gonna write this is out of. So it's probably the picking a female out of people who live in coastline. So in this case, out of C, right? So see, there are 34 people only. So number on the bottom is going to be 34. That's coastline. And out of those, the female, there are 18 females, right? So I have one hand, I have 45 over 100. And on the other hand, I have 18 over 34. I just want to make sure they're actually not the same number. Or maybe they're the same number. So 45 over 100 is 0.45. And if I calculated the other one, 18 divided by 34, I get 0. I need more space here. This is 0.529. So they're not equal. So my final answer is they're not independent. Not independent. More space here, independent. Again, for some questions, these two numbers will come out equal. That means I'm going to say that they are independent events. All right, let's look at number 3. Find the probability that person is male given, okay, I'm going to highlight given right here, that person prefer hiking near lakes and streams. All right, so part A, what word tells you this is conditional? The given. That's like a keyword. So if I say something, 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 given something, something, then I know we have a conditional probability, which is denoted by this bar. Fill in the blank. It says find the probability the person is male given. So male given the bar, the person prefer hiking near lake and stream. So lake. Oh, that's L. Right. So again, how do I actually calculate the number? Again, I'm going to interpret this as out of lake, right? So let's look at how many people are out of who prefer lake, which is the middle column. So there are a total of 41 people. So in that, my answer is going to be 41 is going to be on the bottom. And then it says male given that. So out of people prefer lakes and streams, how many males are there? There are 25. Let's go back and forth here. So that'll be 25. So that'll be my answer. Hints for number 4 and 5. The difference between 4 and 5. Number 4 is it says they're selecting 2 different individuals, right? This is going to be a multi-stage question. And the last question, let's say part C is asking for F and P. Here, the last question, it doesn't say it's picking 2 people. I'm going to assume they're picking 1 person. So there's no formula. I'm just looking for probability somebody being picked is female and who prefer mountain peak. So basically I just literally have to look at the chart. Female, mountain peak, there are 11. So then my answer is just for that. My answer is 11 over 100. Okay, I'm going to have you finish the rest of the worksheet and we're done.